Hey everyone, so after fixing a Diamond Monster 3D2 in my last video, I'm all energized and ready to face my nemesis, the Trainwreck Voodoo 2. If I'm Mega Man, this thing is Dr. Wily, and no doubt there's going to be a few difficult stages I'll have to get through before the end. So, this card here is a reference design 8MB Voodoo 2 by Creative Labs with model number CT6670. I bought this card on eBay back in October of 2020, over 2 years ago, on a bit of a whim. It was a really great price, but sold quote unquote untested, and you know what that means. It was broken. The listing photos weren't very clear, but man, I was not at all prepared for the mess I saw when I got it. The card was banged up, scratched up, and the entire PCB had a nasty bend to it as well. There were numerous broken off capacitors on this thing. C48 at the bottom right hand corner, C31 near the left TMU, which actually fell off later on. More on that in a bit. On the back of the card, great big one labeled C9 was gone, C128, C81, and C108 as well. There were also a few deep scratches in several places on the PCB, but the worst was this big gouge near the VGA connector. I mean, look at the state of that bracket. How does that even happen? But yeah, two of the traces were completely severed, and pass-through VGA output was broken as a result. There were also many bent and shorted pins on the chips. It's kind of hard to see in the photo, but there's about a dozen pins all folded over here on the frame buffer shorting out, and there were more on the other side that aren't visible here too. Both TMUs had some damaged pins, with a few becoming detached from the pads as well. Thankfully, none were broken off though. After some initial disappointment and buyer's remorse, I picked myself up and vowed to take a crack at repairing this badly neglected card. I started the way many people would. I created a new post on Vogons, and after getting some very helpful advice and eventually being led to a great schematic diagram for the CT6670, I was on my way. I had very little soldering experience back in 2020, especially with SMD components, but after buying a practice kit on Amazon and building up just enough confidence to be dangerous, I made an honest effort. And with nothing more than a magnifying glass and some very basic tools and a lot of patience, I managed to get all of the missing components back on. Yeah, it definitely wasn't my best work, that's for sure. But it was certainly a personal accomplishment for me back then. I was also able to get all the pins straightened out, and I even did a crude bodge wire job to fix the broken traces, which was successful by the way. Pass-through videos started working after that. But the wire I used was just way too thick, so I ended up removing it later on. But despite my best efforts, the card was completely dead. It would get detected in Windows just fine, but I could never get the display properties page to load or any 3D game to launch without immediately freezing up the system. I picked up the card again a couple of times in the following months, and I even managed to repair some detached pins that I found, but never had any luck unfortunately. I considered using it for parts a couple of times and even framing it at one point, but I could never bring myself to give up on it. Although I'm not an electronics repair expert by any means, I have learned a lot since 2020. I've had some success repairing some video cards, sound cards, and motherboards. My soldering and desoldering skills have improved quite a bit, and I've got much better equipment at my disposal now too. I have an oscilloscope, a digital microscope, and much better soldering tools as well. I think it's definitely time to revisit this card again and see if I can apply some of what I've learned over the last couple of years to get it up and running again. So without further ado, let's dive in and see if we can get this thing back on the tracks. So the first thing I want to address is the trace damage near the VGA connector. The wiring that I used for bodges originally was way too thick. I think I actually got it out of an Ethernet cable, so yeah, really wasn't secured well at all because of that. But at least it did prove to me that VGA pass-through could be fixed. I wound up removing it and attempting to do some trace bridges back in 2020, but I just made a mess of things as you can see here. The traces are really tiny and it's difficult to get anything to attach to them. So rather than mess with this again, I'm just going to redo the bodge wire fix, but with more appropriate 30 gauge wire wrap this time, so hopefully it'll look a little cleaner. I'm just adding a bit of fresh flux onto the first solder pad here. I bent the end of the wire into the shape of a hook just to wrap around the pin, and I'm going to reflow the existing solder. There's plenty here on these very large pads, so there's really no need to add more. You can see the hook sort of just disappear down into the blob, and that's nice and secure and not going to go anywhere. The other side of this trace connects to a pin on the VGA input connector, probably why pass-through video is broken. And I'm just going to do the same thing here, and I'm going to bend the wire to keep it out of the way and channel it between the pads. Okay, one down, one to go. So the second broken trace, if I follow it here, leads to a via just behind a small IC on the front of the card. And I'm assuming it's for VGA switching if I had to guess. The copper is mostly exposed, but I'm just giving it a gentle scratch to make sure there isn't any solder mask on top of here. 30 gauge wire is thin enough that I can just bend it and insert it right into the via for a more solid connection. I'm just adding a bit of flux and giving it a quick touch with the iron. I had a very small amount of solder on the tip, and oof, the heat travels up the wire quickly. It warped the insulation where I had pressure on it. I'm just going to squeeze this back into shape. Yeah, going to add just a little more for good measure. There we go. That should do it. And for the last connection near the VGA output. There we go. Nice and secure and looking good. Just going to give this a quick cleaning with some isopropyl alcohol now. And here's the finished product. It's not going to win any awards for a 100% original looking card anymore, but that's okay. That's really not the goal with this project. The connections are nice and secure and the repair should be good. Let's test VGA output just to be sure. And yep, it's working. Excellent. So the next thing I want to address is a bit of a mystery to me. There's a surface mount capacitor labeled C31 on the front of the card near the left TMU that's missing. In this picture I took back in 2020, you can see it's there, but it is definitely gone now. It does look a little sideways in the picture, so I'm assuming it was already falling off to some degree. But anyway, let's get this put back on before we try to test the card out again. Sorry for the bad lighting of this microscope footage. I forgot to turn on the side lamps, but you can clearly see C31 has been broken off. I'm just going to add some flux here and going to try to get the bits of broken capacitor off with my iron. I'm then going to get the old solder off with some copper wick and then get the pads cleaned up with some isopropyl alcohol. Looking good. Looking at the schematic, C31 is a 100 nanofarad 25 volt capacitor in an 0603 size. And thankfully this matched one of the ones I replaced on the back of the card a while back, and I always buy extras. So with the pads all clean, I'm just adding some flux here. And there's a few different ways you can solder small SMD components like this, but you've probably noticed that I like to just pin them down with tweezers and tack one side with a preloaded iron. It takes just a tiny amount of solder on the tip, and you can get pretty clean results this way with some practice. The second side's easy too because it's not going to move after the first side is done. I'm just going to get this cleaned up with some isopropyl alcohol. And here's the final result. Not bad. I also went back and redid C48 since I had some spares. It looked pretty sketchy from my attempt back in 2020, so I feel a bit better about it now. Anyway, this card is now whole again, so let's boot into Windows and see what happens. I really don't expect the card to behave any differently with what I've done so far, but let's get it tested here anyway. As before, it seems the card's detected just fine and loads the driver, and really from the perspective of Windows, looks like a perfectly healthy PCI device. The frame buffer chip on the card is really the brains of the whole operation, so the fact that we're even seeing this tells us the card's at least alive to some degree. But if I open the 3DFX display properties page or try to launch a 3D game, the system just completely hangs up. Thankfully, I can use 3DFX's DOS debugging tools included in their Glide SDK package to get some more useful information. I'm not going to get too into 3DFX environment variables or debugging much in this video, so please be sure to check out my last one if you'd like to learn more about troubleshooting Voodoo 2 cards. I'll include a link to that video in the description below. So running detect looks good. I can see a 3DFX device listed with PCI identifiers and a base address. Let's see if Mojo can initialize this card and provide us with more information. Yeah, really doesn't get very far at all in the initialization process, and the card looks like it just hangs up completely. We're really going to need to check the debug level logging to figure out more. I'm going to need to reboot to recover here. So as you can see, the debug log file is 0 bytes, so because the system hung up like that, it just couldn't write anything to disk. But thankfully there's always the option to write the debug level logging to console instead of to a file. That way we might be able to see something at least before the system hangs. Let's give that a shot. Well, still not a lot going on here, but at least we have some debug logging on the screen. We can see that the board was detected, knows where to find it on the PCI bus, and the address is correct. It also appears to set a couple of registers successfully, so that's good, but it is still freezing up very early on. So back in 2020, I was using a magnifying glass to inspect the card, which was painful to say the least, so I really wanted to start by doing a thorough inspection of the chip pins and the PCB just in case there was something I missed. I started by checking some of the deeper looking scratches on the PCB. Most were pretty superficial, but this one here was pretty nasty looking by the frame buffer. One of the traces had a pretty deep gouge in it, but after checking continuity, all of them seemed okay. I couldn't really see any other damage, so I moved on to the chip pins. You can see the repair job I did on a couple of detached pins here on one of the TMUs. The shinier pins are the ones that I reflowed. They seem nice and secure. But after doing a quick visual inspection, I noticed that the last two pins on the same TMU were looking slightly misaligned. And ooh, look at that. Not attached at all. Not good. May look like I'm struggling a bit here, but I'm just trying to get them lined up properly again. It's quite a bit harder than it looks, actually. Alright, so let's get these things reflowed. Just adding a bit of flux here and a tiny amount of solder to get each pin reattached. And of course, after all that time trying to get them aligned properly, I managed to nudge the first pin crooked again. But that's okay. As long as it's on there well and isn't shorting out, that's all I care. And after cleaning with some isopropyl alcohol, I can see they're nice and secure, and that's another problem fixed. I think the finished product looks pretty good. So after getting those pins sorted, I very meticulously checked every single pin on the frame buffer in both TMUs, which took an eternity. It's a lot of pins. There were a few that looked a little bent, but no shorts, and every single one was securely attached, so I feel a lot better about that now. Since there was really nothing else I could see under the microscope, it was time to test the card again. But sadly, there was no change at all. Don't get me wrong, those detached pins were definitely a problem and needed to be fixed, but it was not the problem holding us back at this point. And besides, an issue with one of the TMUs would probably manifest itself in a bit of a different way. I can't see it causing a complete hang so early on like that. There's definitely something else that I'm missing. So, after thinking about it for a bit, I realized I may not be looking at this the right way. Rather than focusing on the small amount of information that makes it to the screen, I really should be focusing on what I don't see. What should be happening next in the process? Thankfully, I've got some debug logging handy from the other card I repaired, and I can take a look at the expected sequence. The last line that makes it to the screen before the system hangs is the FT clock register being set. And interestingly, the next 12 expected lines are all RAM-DAC related, beginning with the DAC detect routine. Could this card just be failing to detect the DAC? So a DAC, or digital to analog converter, does just what you'd expect on a video card. They take the digital signals and convert them into usable analog output for a monitor. Many cards had this integrated into the graphics chip by the late 90s, but the Voodoo 2 still had an external DAC. It's the ICS 5342, which is actually the same model used on the previous generation of cards. There's a few components on the card related to the DAC, including a very important crystal oscillator that provides the timing the chip needs to work properly. It actually looked a little tilted as if it got knocked or something, so it was one of the first things I checked. And sure enough, after several attempts with my oscilloscope, I was getting no waveform out of the crystal whatsoever. It's definitely an exciting moment to finally find something new with this card, and something that could potentially explain what I'm seeing in the logging too. The crystal used by the DAC oscillates at a very common 14.31818 MHz, and is actually very easy to source these days. I got these crystals here from DigiKey for about $1 each, and for anyone wondering, the crystal type required is HC49U. So I'm using my hot air station here to remove the old crystal. I just put some Kapton tape around some nearby passives to prevent them from getting disturbed, and a fair bit of flux on the crystal itself as well. And after a bit of patience, it came right off without issue. I'm just getting the old solder off the pads here with some copper wick, and as always cleaning up the flux residue with isopropyl alcohol afterwards. The pads are looking nice and clean and should be ready for the new crystal. So in hindsight, I probably didn't need to solder it on this way because the pads are long enough, but this is the way I usually solder on surface mount electrolytics. I tin one of the pads ahead of time, heat it up, and then just slide the component into place. This really helps when the pads are short and there isn't a lot of space to make good contact with your iron. Sorry again for the bad lighting here, but as you can see, I just heated up the pad and I put the crystal into position. But yeah, there's definitely enough pad exposed to just solder this the normal way. So after getting it all cleaned up, I think it looks pretty good. Let's see if we can get a waveform out of this thing now. Nope, nothing at all. But it didn't take me long to realize that in my excitement, I got way ahead of myself. Instead of just assuming the crystal was bad, I should have asked myself why it wasn't oscillating. In order for a crystal oscillator to oscillate, it obviously needs some power applied to it. And if I had just taken an extra second to check it with a multimeter, I would have seen that it's not receiving power. No power, no waveform. After referring to the datasheet, I could see that the crystal is connected to pins 48 and 49. There's also a small SMD capacitor on each trace, which is common for circuits with crystals. But after doing some continuity testing, everything looked fine. Why is the DAC not driving the crystal? Could the DAC itself be bad? Whoa, I better not get ahead of myself again here. Going back to the datasheet, I can see that pin 50 is for the oscillator's power supply, but it looks like it's just supposed to connect to the AVDD pin, which is basically the main 5-volt power input for the DAC on pin 41. So let's check that real quick here. Aha, there we go. All is explained. The DAC has no power going to it at all. So it's obviously not going to be powering a crystal, and that makes perfect sense. Next order of business is to trace where the AVDD pin leads. It's the third pin from the right, and you can see a nice thick trace leading to a via here. And if I flip over the card, I can see it leads to a large 5-volt power plane. So basically every component fed by this plane is not getting power. I should mention that the frame buffer and TMUs are not 5-volt chips. They get their 3.5 volts or so from the regulator on the front side of the card. But the memory is 5 volts, and I'm pretty sure it's getting power from somewhere else. Let me do the old finger test here. Oh, what the? That is hot. The chips were just lukewarm, but not this one on the frame buffer. Wow. Yep, that's me burning my finger over and over again as if I don't believe it or something. This definitely warrants a look with my thermal camera here. And wow, that picture really makes it pretty clear. That chip is just cooking itself. Not a good sign at all. It's pushing 80 degrees. I have seen this happen on one other card, and I assume it must be due to some kind of an internal short on it or something, but I'd say there's a very good chance that chip will need to be replaced. But anyway, as if this card doesn't have enough problems already, let's just add this to the list and get back to the DAC power issue at hand. So I need to figure out where the plus 5 volts is coming from on this power plane. There isn't a clear trace leading from the PCI power pin, so my attention shifted to these surface mount components labeled FB on the card. Although they look like capacitors, FB stands for ferrite beads, which are basically just filters used to remove high-frequency noise. Filters like this are often used for power filtering. Two of them labeled FB1 and FB2 look particularly interesting. They have thick traces like you'd expect for power, and if I follow the vias to the opposite side of the board, one end is on the power plane and one isn't. Pretty sure FB2 is going to the plane in question, but FB1 might be energizing a middle layer on the PCB that I can't see. I'm not 100% sure. Checking with the multimeter, I can see the full 5 volts on the outside pad, but on the inside, I get nothing at all. Ferrite beads like this should have a very low impedance, practically 0 ohms, and when I check these two, they're reading an infinitely high resistance. It's basically like these pads aren't connected at all. So I think we've finally found the problem here. I'm not sure if these failed due to mechanical stress from the PCB being bent or something, or if they failed due to exceeding their current rating, maybe from a short or something. But I did check to make sure that the power plane wasn't shorted to ground, and it looks fine, so I think it should be safe to just replace these and see what happens. Let's get these dead filters off the card. I'm going to try without using my hot air station this time. They're small enough that I may be able to get them off just with a thicker iron tip. I'm just adding some fresh flux here. I'm going to heat up the component a bit to get the solder flowing on both sides. And oh, look at that. It totally split in two. I'm not sure if it was the heat responsible for that, but I suspect it may have been already broken. But that definitely doesn't look right to me. There we go, first one off. Second one cracked too. I didn't apply heat nearly as long that time, so I'm pretty sure these were damaged due to mechanical stress a long time ago. Yeah, look at that, cracked cleanly right across. I can't say I have a lot of experience with SMD filters like this, but let me know what you think in the comments. Next, I'm just going to use my iron here to remove the broken bits from the pads, and then I'm going to use some copper wick again to get these pads cleaned up. And as always, I'm going to use some isopropyl alcohol just to make sure they're nice and shiny. And yep, they're looking good for the replacements. So once again, the CT6670 schematic totally came in handy. I could see that FB1 and FB2 are rated for 600 ohms at 100 megahertz, and they should be at least 0.5 amps rated or greater. And the package size needed is 1206. Thankfully, these are very common and were easy to find at DigiKey. They're just a few cents each, so I bought some extras just in case. These ones here are made by Worth, and they're rated for 2.5 amps, so should be fine. Soldering these on should be no different than any other surface mount capacitor or resistor, and I'm going to use the same technique by holding it down with some tweezers while tacking it on one side. I find it kind of funny that I spent so much time trying to line it up just right, and of course I end up soldering it on a bit of an angle anyway. Oh well, that's okay, as long as it works. And for the other side, I'm going to add just a bit more for good measure here. There we go, that looks good enough. Time for FB2. Yeah, that one went on a lot better. So after cleaning the area up, I'd say it looks pretty good. Let's see what it looks like with the multimeter now. 0 ohms for both. Excellent. I think this thing's ready to test. So let's get it back in the system and see if our DAC has power. Aha! The crystal is now reading 1.3 volts and the power pin of the DAC is now getting 5 volts. Alright, fantastic. Let's take a quick look at the crystal with the oscilloscope just to make sure we're getting the expected 14.3 megahertz now. And yes indeed, nice and clean looking. I'd say this DAC issue is fixed. So I was just getting ready to start looking at that 80-degree EDO chip again, but to my surprise, it's the same temperature as the others now. I really don't think anything I did with those filters should have had any bearing on the memory at that end of the card, so I'm really at a loss for why this problem just suddenly stopped. I did clean up some flux residue from around that chip after replacing one of the capacitors earlier, but I'm still skeptical. If you have any theories, I'd love to hear from you in the comments below. Anyway, I think we're finally ready to test this card again. Let's see if we get any further with Mojo. Oh wow, that looks like a full initialization happened and we're getting everything we'd expect. The frame buffer's there, both TMUs are there, all the detected memory amounts look right. Wow, way more promising than I expected, to be perfectly honest. Let's have another look at the debug logging now. And yeah, that looks great. The DAC is detected fine now, and I see debug level reads and writes reported. Everything looks like what I'd expect from a working card, so that's fantastic. So right off the bat, I can see that the 3DFX display properties page is working now. Really awesome. I never got this far with a card before. Everything looks good in system information as well. Could this be it? Are we really ready to finally launch a game? All right, it's time to test a game. I gotta say I'm quite nervous here, but let's see what happens. GL Quake, here we go. Oh, I see the logo. Yes, it works. Look at that. It is working. Fantastic. So the train is back on the tracks. I don't think we can declare success quite yet. Let's launch a more demanding game and put some prolonged stress on the card. And what better way to stress test than to actually enjoy some Unreal Tournament? And yeah, I forgot how much fun this game was. Really loved it back in the day. But yeah, everything's looking great. No texture corruption, no other weirdness going on. I think I'm pretty convinced. I still don't quite trust that memory chip that went nuclear on me though. I'm going to keep a very close eye on it. Even after hours at full load, they really didn't get past 40 degrees, which just goes to show how ridiculous 80 is for one of these. But I may have some plans to upgrade this card from 8 to 12 megs, and if I do that, I'm going to replace that chip as well for good measure, so stay tuned. Not quite done with this card yet. Well, I gotta say, that feeling never gets old when you finally see a broken card like this spring to life for the first time. Especially one with such a history like this. This card taught me so much back in 2020, and it taught me so much again here today in 2023. And although that purchase felt like such a bad deal back then, the experience I gained has been incredibly valuable. And I never thought I'd say this, but I am thankful that I bought the Trainwreck Voodoo 2. I know this was pretty long for a repair video, so thanks for sticking it out if you made it this far. I hope it was as entertaining for you as it was satisfying for me to finally get this card working again. Thanks so much for watching, and please don't forget to like and subscribe if you'd like to see some more content like this. And as always, be sure to check out the video description for more information, useful links, and where to find me on Twitter and Mastodon. And you'll find a link to my blog down there as well. Thanks again.